Welcome to the NIME workflow named Data5. This workflow uses the customer scores database without missing data to illustrate how variable transformation works in NIME. The workflow starts by loading the customer scores database, in particular the customer scores database without missing data. This is implemented using an XLS reader node. Then we partition the customer scores database in two partitions A and partition B using the partitioning node. We set up the partitioning as follows, selecting the configure option, and we select to have a partitioning where we use the relative percentage option, and in particular we set the portion of the data to be included into the first partition, so into partition A, to be equal to 50. The same applies to the second partition, so to partition B. We also make the decision to use a random sampling, and we do not select any random seed. Then we focus our attention for showing how the variable transformation works in NIME on a single attribute. In particular, we make the decision to use the day_means attribute. To select just this attribute, we use the node column filter, which can be found in the data manipulation column filter section of the node repository. We set up this node again by right-clicking the button of the mouse, selecting configure, and adding to the list of the included attributes just the day_means attribute. Then we execute this node and we are ready to describe which are the different options that NIME makes available for us for variable transformation. The first option that NIME offers to us is the normalizer node. The normalizer node can be found in the section Data Manipulation, Column and Transform. This node normalizes the value of all numeric columns, and in particular in the dialog you can choose the columns you want to work on, and the following normalization methods are available in the dialog. You have the min-max normalization, the z-score normalization, and the normalization by decimal scaling. In particular, this normalization is such that the maximum value in a column, both positive and negative, is divided j times by 10 until its absolute value is smaller or equal than 1. All values in the column are then divided by 10 to the power of j. However, we are not gonna show in the use of this specific option. We move back to the normalized node, and to set up this node we simply right-click the bottom of the mouse, we select the configure option, and the following window opens. In particular, we select the attribute that has to be used for variable transformation, and here in this area, in the settings area, we have the three options that I have listed before. We have the min-max normalization. In this case we have to specify which are the extremes of the interval used for the normalization. In our case we set 0 and 1. You can select the z-score normalization, or you can select the normalization by decimal scaling. In this case, we select the min-max normalization and we let the extremes of the interval to be 0 and 1. Then we close this window, and once we have executed this node, we can summarize the results of what we have achieved using the statistics node. However, we use two different nodes here, two different instances of the node normalizer, and in particular the first one concerns the min-max normalization, while the second one, as well as we can see from the window, concerns the z-score normalization. Also in this case, we use the normalized data to compute summary statistics, and with this node, the concatenate node that we have already described in previous 9 workflow, we compare the results of the two different normalizations that we have applied to the day-means attribute. To configure this node, we simply again select configure, and we simply make the decision to use the union of the columns. Then we can access the output of the concatenate node simply selecting the concatenated table. In such a case, we will have the two different instances of the day means. This is the day means which have been applied the min-max normalization, while this is the instance of the day means which was applied the z-score normalization. Indeed, we can see that the mean and the max for the first instance are 0 and 1 as we set it up. Then the mean is 0.517, the standard deviation is 0.156, while for the second instance, which is the normalization based on a z-score, we have that the minimum and the maximum range from minus 3.32 and 3.10, and the mean is equal to 0. This is by definition, obviously. Also, the standard deviation is equal to 1, and again, this happens by definition of Z standardization. Then we can close this comparison node, and we need also to emphasize that the normalized node is paired with a normalized apply node, which is particularly useful to apply the same normalization to records that were not used to build the normalizer. So the normalized apply is used to apply the normalization that has been computed with the normalizer node to records, to new records. For example, in this case, it is applied to the records belonging to partition B. Finally, we also have the denormalizer node, which allows us to go back from the normalized values again to the original values. And in this case, it is clear that we can access the output of this denormalization simply selecting the denormalized option. We focus in particular the attention on the day means attribute. This is the result of the denormalization, but we can also access the same table when we have normalized attributes. And so what we get in this comparison is that the normalized values of the day means, as well as we can see, are takes small values, so they are distributed according to the z-score measure. In this case, the day means values for exactly the same record are brought back to the original values. We can now close these comparison windows, and we can focus the attention to the math formula node. The math formula node is a node that NIMES makes available to us to compute any formula that can be useful. In particular, to set up the math formula node, we again right-click the bottom of the mouse, we select Configure option, and the following window open. So now we can select the list of the columns of the attributes that can be used to make computation. Eventually we have a list of flow variables, but in this case it is empty, and here we have the set of the categories of different functions that can be used. We have constant, we have exponential function, logarithmic function, logical function, and so on. And here in this area, in the area function, we have the list of all the functions which can be used by the math node. In our case, we simply want to compute the natural logarithm of the day means, and we will append a new column which is called log of day means. We do not make the decision to replace the column in this case. After having executed this node, we can access the output of this computation using an interactive table. In this case, we select the view table view, and here we can compare the original values of the day mean attribute with the transformed variable, which is the log of the day means. We conclude this workflow by introducing an extremely interesting node, which is the one-to-many node, which is included into the data manipulation column transform environment. In this case, the one-to-many node is used to apply binarization to categorical attributes. The one-to-many transforms all possible values in a selected column, each into a new column. The value is set as the new column's name, and the cell values in that column are either 1 if that row contains this possible value, or 0 if not. Just to show how the one-to-many works, we right-click the bottom of the mouse, we select the configure option, and then we can select on which of the categorical attributes the one-to-many node has to be applied. In our case, we select simply the state attribute that we know can take many different values, and we apply the binarization to this specific attribute. Then we use the column filter node to reduce the number of attributes to be analyzed. In particular, we simply filter in the state attribute and all the additional attributes which have been added as a result of the one-to-many node execution. And finally, we can access the output, the result of the one-to-many execution, through the interactive table. In this case, we can select the view table view, and here is the result. We have here the attribute state, we have the records that are indexed by the row ID. This is the value of the state attribute for the first record, for the second, and so on. And here we have all the new attributes, the binary attributes, which are associated with all the possible values that the attribute state can take on. So we can see that if the value of the state attribute is equal to ks, as it is here, then only the ks binary attribute is equal to 1, while all the other attributes are equal to 0. So in other terms, this is simply a binarization process.